Okay, so we will move to our next chapter, and this chapter mostly focuses on multiple integrals. So first of all, what does multiple integral means? So multiple integrals, in very naive way, multiple integrals means that in case of single integral you have only one integration sign involved and you are to integrate with respect to only one variable. But to solve some physical and biological problems, you may need to have solve integration around not only at one variable, rather two variable. I will give you an example. So y equal to square root of x. This y equal to square root of x is a parabola. Now you just rotate this parabola 360 degree around this x axis. So what it will become? It will become a this type of 3D shape. Now you may be interested to determine the area that of this 3D surface, the area of this 3D surface. Okay, so these kind of problems are referred to as surface of revolution, and this solid that it will construct due to this parabolic shape to move around the revolve. So therefore this thing will called solid of revolution, and this y equal to x line, this will be called axis of revolution. Okay. Now I will just go to the theory part. I will upload the note, so it will be easier for you to learn also, to read whatever I discuss here. So what will be the answer? The answer will be v equal to a to b ax dx, or in other words, this expression for this v will be integration a to b pi into fx square dx. And here what is your y? Fx, your fx is square root of x. Now, so the region bounded between the curve y equal to square root of x, 0 less than or equal to 1, x less than or equal to 4, and the x axis is revolved around x axis. You need to find the volume of the solid revolution. As shown in the above figure, the required volume will be therefore v equal to square integration 0 to 4 pi square root of x whole square dx, or 0 to 4 pi x dx, or pi x square by 2, 0 to 4, 8 pi. Therefore the volume of the solid of revolution will be pi y square dx. And similarly, if you have some parabola like this, x equal to square root of y, and you would have rotated along this y axis, then the expression for will be pi x square dy, and that x will be in terms of y, so x will be fy. So you need to find the volume of the sphere x square plus y square plus z square equal to a square. A is greater than 0. Okay, so we think of the sphere as the solid of revolution of the region bounded by the upper semicircle x square plus y square equal to a square. Y is greater than or equal to 0. Here minus a less than or equal to x less than or equal to a. The curve is the square root of a square minus x square. Then the volume of the sphere will be v integration minus a to a pi square root of a square minus x square whole square dx. So that will be minus a to a pi a square minus x square dx. So that will be pi into a square x minus x cube by 3 minus a to a 4 by 3 pi a cube. Next you need to find the volume of the solid obtained revolving by the region bounded by y equal to square root x and the lines y equal to 1 x equal to 4 about the line y equal to 1. Okay, so now what will be this distance? This distance is square root of x minus 1 whole square. It will be square root of x minus 1 whole square, and your limit of the integration will be, you are rotating about this y equal to 1 axis, so your limit of integration will be 1 to 4 pi rx whole square dx, 1 to 4 pi square root of x minus 1 whole square dx, 1 to 4 pi x minus 2 x root x plus 1 dx. If you integrate it, it will give you 7 pi by 6. I am just keeping this slide for some time. You just carefully go through whatever I have written here. Okay. Okay, next problem is you need to find the volume of the solid generated by revolving the region between the y-axis and the curve xy equal to 2, where 1 is less than or equal to y less than or equal to 4 about the y-axis. Okay, so you have curve xy, you need to rotate it about y, so you need to replace x in terms of y, so it becomes x equal to 2 by y. Your y you need to vary it from 1 to 4, so x equal to 2 by y, so v will be 1 to 4 pi ry whole square by 4 by y square dy equal to, this will be equal to 3 pi. Find the volume of the solid generated by revolving the region between the parabola x equal to y square plus 1 at the line x equal to 3 about the line x equal to 3. Notice that the cross section are perpendicular to the axis of revolution x equal to 3. The volume is v equal to minus square root of 2 into square root of 2 pi ry square dy minus square root of 2 to 2 pi 2 minus y square whole square dy 64 pi into square root of 2 by 15. So if the region which revolves does not border the axis of revolution, then there are holes within the solid, just like here you have holes, and in that case v will be a to b ax dx, a to b pi rx square minus small rx square dx. Next, find this problem. The region bounded by the curve y equal to x square plus 1 and the line x plus y equal to 3 is revolved about the x-axis to generate a solid. Find the volume of solid. The outer radius of the washer is rx equal to minus x plus 3 and inner x equal to x square plus 1. So the limits of integration are obtained by finding the points of intersection of the given curves. So x square plus 1, okay, x square plus 1 equal to minus x plus 3, so your x is minus 2 and obviously 1. So the required volume is pi integration minus 2 to 1 pi pi minus x plus 3 whole square minus x square plus 1 whole square dx 117 pi by 5 is your answer. I am giving you 2 minutes to please see whatever is happening. Okay, so next problem is you need to find the volume of the solid obtained by revolving the region bounded by the curves y equal to x square and y equal to 2x about the y axis. You need to find the volume of the solid bounded by revolving the region bounded by the curves y equal to x square and y equal to 2x about the y axis. See, same pi ry whole square minus ry whole square dy. So what is your ry here? This will be y and this will be y by 2. So square root of y minus y by 2 whole square. If you just integrate it, it will become 8 pi by 3. Now I also request you to please next. B is C. Problem in the figure is shown. This problem I will not discuss to you. This problem will be your home task. Just closely look whatever the technical things this problem needs. This is a very difficult problem, and if you can solve this, you can solve any problem in my opinion. So I am just skipping it. Next problem is a wedge is cut out of a circular cylinder of radius 4 by two planes. One plane is perpendicular to the axis of the cylinder. Okay, so this is perpendicular like this, and other one is as an angle of 30 degree along a diameter of the cylinder. Find the volume of the wedge. Okay, so this slice is cut from this. This slice is cut from the this cylinder. So if we place the x-axis along the diameter where the planes meet, when the base of the solid is a semicircle with equation y equal to square root of 16 minus x square minus 4 less than or equal to 8 less than or equal to 4. A cross section perpendicular to the x-axis at a distance x from the origin is the triangle ABC, whose base is y equal to 16 square root of 16 minus x square and height is y tan 30, and tan 30 is 1 by root 3, so that it becomes square root of 16 minus x square root 3. So the sectional area will be, so this is how I am constructing the triangle. Okay, and then this triangle is need to integrate. So the the area of the triangle is yes, okay. So now the area of the triangle will be, we know that it becomes half into excuse me, half into base into altitude, and here your base is square root of 16 minus x square, your altitude is y tan 30, that means square root of 16 minus x square by square root of 3, and then it becomes 16 minus x square by 2 root 3. Then the required volume of the wedge is V equal to minus 4 to 4 ax dx. In other words, minus 4 to 4, 16 minus x square by 2 root 3 dx, and if you integrate it, 128 by 3 root 3 will be the answer. I am just giving you this question is bit tricky. I am giving you 2 to 3 minutes. Just carefully look whatever I have done. Okay, so next problem is you need to find the volume of the solid generated by revolving about the x-axis. The region bounded by the curve is y equal to 4 by x square plus 4, and the line x equal to 0, x equal to 2, and y equal to 0. Okay, so what will be your, you just need to put x equal to 0, x equal to 2. So your integration is x equal to 0 to x equal to 2, and there are 2y, y 4 by x square by 4, and this will be y equal to 0 square. So your answer will be pi ry whole square minus small ry whole square. So capital Ry is 4 by x square plus 4, and small ry is 0. So this will become pi into 16 by x square plus 4 whole square. You take x equal to 2 tan t. So ds equal to 2 sec square t dt. So x square plus 4 whole square, it becomes 16 sec to power 4 t for 0 less than or equal to t less than or equal to pi by 4. So v becomes 0 to pi by 4, 16 pi 2 sec square t by 16 sec to the power 4 t dt, integration 0 to pi by 4, 2 pi cos square t dt, pi into 1 by 4, pi into pi by 4 plus half. So this will be your answer. Once again I am giving you 1 minute to just okay. So next problem, once again the approximation of volume part. Next, okay, so see, you need to find the volume V of the solid raised over the rectangle 0 to 1 to 0 to 2 and 1 above the plane z equal to 4 minus x minus y. We proceed as follows. So this is your domain R. Your integration is 4 minus x minus y. You just need to integrate from 0 to 1 and 0 to 2. You will get the answer. Next, there is also a theorem called Fubini's theorem. So what does Fubini's theorem mean? So Fubini's theorem means that if you have a rectangle a to b cross c to d, and if your f is a mapping from this R to the set of real line be a continuous function, then double integration over R fxy dy dx is a to b c to d fxy dy dx c to d a to b fxy dx dy. That means that if your fxy is a continuous function, you can change the order of the integration. That means whatever dy dx means, the dx dy, if you integrate in that order also, you will get the same result. Evaluate double integral R 1 minus 6 x square y dA, where R equal to 0 to 2 into minus 1 to 1. So this becomes 1 minus 6 x square y dA minus 1 to 1, 0 to 2, 1 minus 6 x square y dx dy minus 1 to 1, then x square you integrate it x minus 2x cube y. So you integrate it over x. So if you just 2x cube, so that 2x cube x cube will give you 2. So from here you can get 2 minus 16y dy. Then once again integrate with respect to y, you will get 4. Similarly, if you just integrate in the reverse order, that means instead of dx dy, you first compute integration with respect to y. Then from here you will get y minus 3x square, 1 minus 3 1 minus 3x square y square. Then you put the value of, so first it is y with respect to y, so that will become y minus, oh I think I have done here some mistake, minus 1 2, okay, sorry, I got it. So see, this minus 6x square y square will give you y minus 3x square y square, and 3x square y square is an even function. If you integrate it over minus 1 to 1, it will give you 0. So from here only you will get 2 dx, because 1 minus minus 1 will give you 2. So 0 to 2 dx will give you 0 to 2 dx equal to 4. And also if you integrate this y sin xy dA, where r equal to 1 to 2 to 0 to pi, then you will get the value to be 0. What does it signify? It signifies the net volume is 0. Next, find the volume of the solid bounded by the elliptic paraboloid x square plus 2y square plus z equal to 16, and planes x equal to 2, y equal to 2, and the 3 coordinate planes. Let R be the rectangle 0 to 2 to 0 to 2. The solid is above R and below the surface defined by z equal to fxy equal to 16 minus x square minus 2y square, where f is defined on R. So V is double integration R 16 minus x square minus 2y square dA 0 to 2 0 to 2 16 minus x square minus 2y square dx dy. This will give you 48. Okay, so you need to find the volume of the solid bounded by the elliptic paraboloid x square plus 2y square plus z equal to 16, planes x equal to 2 and y equal to 2, and the three coordinate planes. Let R be the rectangle 0 to 2, 2, 0 to 2. The solid is above R and below the surface defined by z equal to fxy 16 minus x square minus 2y square, where f is defined on R. So V becomes double integration 16 minus x square minus 2y square dA, 0 to 2, 0 to 2, 16 minus x square minus 2y square dx dy. That will give you 48. So here I will discuss something called change the order of integration. Sometimes it becomes difficult to solve in one order, then you can just swap the orders and then you can solve the integration. So for example, let fxy be a continuous real valued function on a region R. If R is given by a less than or equal to x less than or equal to b, and your y gives the values of g1x and g2x, when g1, g2, a comma b to R are continuous, then this double integral R fxy dA to a to b g1x g2x fxy dy dx. If R is given by c less than or equal to y less than or equal to t, h1y less than or equal to x, h2y less than or equal to, where h1, h2, c comma d to r are continuous, then this fxy dA can be replaced as c2d h1y h2y fxy dx2y. I will come obviously to this type of integrations. So here you see, find the volume of the prism whose base is the triangle in the xy plane bounded by the lines y equal to 0, x equal to 1 and y equal to x, and whose top lies on the plane z equal to 3 minus x minus y. So now your v is 0 to 1, 0 to x, y varies from 0 to 1, y varies from 0 to 1, and your x varies from 0 to, y varies from 0 to x, 3 minus x minus y. This 3 minus x minus y you need to integrate it, and if you integrate it 0 to 1, so 3x minus 3x square by 2 dx, it will give you 1. So v will give you 0 to 1, y to 3, 3 minus x minus y dx dy, 5 by 2 minus 4y minus 3y square plus 3y square by 2 dy equal to 1. Suppose R is the region bounded by the line x plus y equal to 1 and the portion of the circle x square plus y square equal to 1 in the first quadrant. You sketch it and then finds the limit. So once again, if you have this type of circular thing, then you can also use, for circle you can also use this type of transformation. Okay, so here what I have written, see, for evaluating double integral as an iterated integral, choose some order, first x next y. If it does not work or if it is complicated, you may have to choose the reverse order. Evaluate integration R, just example, sin x by x dA, where R is the triangle in the xy plane bounded by the lines y equal to 0, x equals to 1 and y equal to x. Here the triangular region R can be expressed as x comma y, 0 less than or equal to y less than or equal to 1, y less than or equal to x less than or equal to 1. So this becomes R sin x by x dA, 0 to 1, y to 1, sin x by x dx dy. We are stuck, no way to proceed further. On the other hand, if you just swap it, you will get it as 0 to 1, 0 to x sin x by x dx dy. First integrate with respect to dy, so your sin x by x is constant. So 0 to 1 sin x by x into x, you will give you sin x dx, and this will become sin x by x 0 to x dy x dx. So dy will give you x, so sin x by x, x will cross, so you will get 0 to 1 sin x dx will be minus cos 1 plus 1 will be the answer. So that is how Next, you need to evaluate the integrated iterated integral 0 to 1 x to 1 sin y square dy dx. Write d 0 less than or equal to x less than or equal to 1, x less than or equal to y less than or equal to 1. We plan to change the order of integration. 0 to 1 x to 1 sin y square dy dx, x to 1 तो ये आ जाएगा 0 to y. So 0 to 1 0 to y sin y square dx dy, you will get y sin y square dy, and y sin y square dy, it is just like you can write is half into sin y square into d of y square. So this will give you minus cos y square half into 1 minus cos 1. There will be bracket close, and there are some inequalities. I will not just for sake of convenience I am just writing it here, just like integrations on a simple line. The integration on planes also has some like it also follows some properties which they actually satisfy. Okay, so here I am given about those properties. Here I have written about those properties. Let fxy and gxy be continuous on a domain D. Let C be a constant function. So constant multiple you just will be same. You can take the constant out, some difference, additivity, domination, area and boundedness. So 1 into dx dy, if you take the double integration of 1, you will get just the area of the D. Polar coordinate also I will not go to in detail. Just one thing remember, that just like we have dx dy in Cartesian coordinate system, here we will get as r d theta dr or r dr d theta, whatever you may call it. Okay, find the limits of integration for integrating r theta over the region r that lies inside the cardioid but outside the circle x square plus y square equal to 1. So in polar coordinate system, r equal to 1 is the circle. Now r equal to 1 plus cos theta. So better write the circle as r equal to 1. So you will need to vary 1 to 1 plus cos theta minus pi by 2 to pi by 2, because how you are rotating, that is also a important thing, that you need to rotate it like here to here. Okay, you know how a cardioid is formed. I will just show you a video. Just see how cardioid is formed. See, so a circle is rotating over a circle. This becomes a cardioid. Very nice illustration. Also there is some illustration called Limacon. I will show you. And this is how Limacon is formed. This is a Limacon. Now if this point you take from here, it will give you a cardioid. So cardioid is a special kind of Limacon. Okay, so here you need to rotate the theta from minus pi by 2 to pi by 2. and your r varies from 1 to 1 plus cos theta f r theta r d theta, 0 to 1 0 to 1 minus x square plus y square dy dx. So here just we need to integrate it over f r theta d r d theta, because f r theta is not given, so that will be just simply here. Next, evaluate I equal to 0 to 1 minus x square plus y square dy dx. This is also a very nice problem. I am giving you few minutes just to solve this problem. Okay, so I equal to 0 to 1 minus x square plus y square dy dx. The limits of integration say that the region is the quarter of the unit disk in the first quadrant. 0 theta equal to pi by 2, x square plus y square equal to 1, r equal to 1. So 0 to 1, 0 to pi by 2, r square into r dr d theta, 0 to pi by 2, 1 by 4 d theta. This becomes pi by 8. This is a very easy problem. Next, I am giving you one more problem. Solve this. Evaluate I equal to minus 1 to 1, 0 to 1 minus x square e की power x square plus y square dy dx. Solve this problem. Okay, so how you need to integration in polar forms? So your theta, it varies from 0 to pi, and your r varies from 0 to 1. So this becomes 0 to pi, 0 to 1, e की power r square r dr d theta. In other words, 0 to pi half e की power r square 0 to 1 d theta, 0 to pi e minus 1 by 2 d theta. So final answer will be pi by 2 e minus 1. Next, evaluate r 3x plus 4y square dA, where r is the region in the upper half plane bounded by the circles x square plus y square equal to 1 and x square plus y square equal to 4. So r equal to r theta 1. So I just solve. I am giving you 2-3 minutes. You just solve on your own. Then I will discuss the problem. next problem. So 3x plus 4y square dA, where R is the region in the upper half plane bounded by the circles x square plus y square equal to 1 and x square plus y square equal to 4. So 3x plus 4y square dA, you just convert in the polar coordinate में x reduce होता है r cos theta, three x plus 4y square 0 to pi. So this becomes 7 cos theta plus 15 sin square theta d theta, 15 pi by 2. So I need to find the area closed by one of the four leaves of the curve r cos 2 theta. R cos से देखो r equal to cos 2 theta. So these are called. Then the required area is integration r dA minus pi by 4 to pi by 4, 0 to cos 2 theta, r dr d theta, minus pi by 4. So this is just like this rotation, this is for 90 degree, this is 3 pi by 2, and then it is like that. So here this is 190 degree, here this is another 90 degree, here this will be another 90 degree, here it will be just, so they are symmetrical. So you just need to multiply with 3 to entirely determine the area. So integration r dA minus pi by 4 to pi by 4, 0 to 2 cos 2 theta, r dr d theta, minus pi by 4 to pi by 4, cos square 2 theta minus 1 by 2 d theta, minus pi by 4 into pi by 4, cos 2 theta minus 1 by 4 d theta equal to pi by 8. So this will be your pi by 8. So this will be your answer. So thank you. Nobody is joined today, but I will upload the note. Thank you very much for joining some people, and I'll upload the note.